regulating blood pressure, helps killing falling in bed and so on. That could be a biochemical component of a long-term memory. So then in 1992, NO was selected the molecule of the year in Science magazine. And 6 years later, Nobel Prize in Physiology of Medicine went to 3 scientists who discovered NO as a signaling molecule in the cardiovascular system. You are unable to predict the functions or properties NO from any detailed examination of the properties of nitrogen and oxygen. So NO is NO, and the properties are unpredictable from the nature of the nitrogen and oxygen. Well, this is a simple inorganic molecule, but also the more precisely structured organic compounds are also very useful to human beings. Well, chemistry is strongly connected with our life. Jim Watson mentioned life is simply a matter of chemistry. Well, now the more than 2,000 pharmaceutical drugs are on market. And these are 5 most useful pharmaceutical drug structure. Without such compounds, pharmaceutical drugs, you are unable to survive. So these are precisely structured pharmaceutical drugs. Well, notably, for instance, atorvastatin or Lipton could reduce the cholesterol level. And the annual sales of Lipton or atorvastatin is now $15 billion in a year. Well, that's based on the discovery of this company is based on the end of the discovery of the 30 years ago. Now the world market of the pharmaceutical drug exceeds $500 billion. That's enormous. So the important is how to discover such an important drug, such as atorvastatin or Lipton. So chemistry plays a key role in the discovery and the development and also manufacturing. Well, so far, the important pharmaceutical drugs were discovered by a trial and error approach. But here you show the modern drug development based on genomic and proteomic science. But in 2003, the human genome structures were fully elucidated through extensive international collaboration. And we know the nature of the human genomes. And now researchers started to work on the properties and function of the proteins which are formed through transcription of the corresponding RNA. The pharmaceutical drugs is a small organic compound which promote or prohibit the function of the such a protein compound. So how to discover, develop, and manufacture such efficient drugs where chemistry plays a key role? Well, you may ask me why the Lipton or atorvastatin lower the cholesterol level. Well, it's because that atorvastatin or Lipton binds strongly the HMG-CoA reductase thereby prohibiting the biosynthesis of cholesterol. So you see the tiny atorvastatin is bound strongly to the such a enzyme in such a way. So here you see the very precise molecular recognition between the very large protein and small component. Well, at Laureate, we are doing the research on such a basic science. However, the utility of the such a knowledge in the basic science is enormous. Some 5 years ago, U.S. Academy, National Academy of Engineering, characterized the 20th century as a century of innovation, and they selected 20 most useful technology which changed our civilized society. The first, most important technology is electrification, which is followed by automobiles, airplane, water supply and distribution, electronics, radio and TV, structural communication, computers, telephony, air conditioning and refrigeration, etc. Well, this list shows that the contribution of chemistry is enormous. Chemistry is everywhere. Without chemistry, you are unable to drive cars, you are unable to fly airplanes or spacecraft, or you are unable to drink water because the water is supplied by using very cheap and durable polyvinyl chloride. And also some small chemicals enhance the food production and also cure the painful diseases. So without chemistry, you are unable to survive. So the chemist should be proud of your own profession. So here, particularly important is catalysis. Without catalysis, you are unable to provide or manufacture the chemicals which are used in such a technology. The most important is the most useful compounds are artificial. Of course, the naturally occurring compounds are extremely important, but that's not enough to support our civilized society. We need artificial compounds which were discovered, manufactured by the power of chemistry. Well, if I'm asked to select one most important catalysis, then I will choose the Haber-Bosch process. Nitrogen reacts with hydrogen to produce ammonia. That's a basic fertilizer. Without this process, you are unable to survive at all. Right? Well, however, the important is that nitrogen doesn't react with hydrogen without catalyst. So two German Nobel laureates, Fritz Haber and Karl Bosch, discovered such a catalytic process after 10-year endeavor. Then we can produce ammonia in a large quantity, then you can produce food. Otherwise, you are unable to survive today. What's a catalyst? As I mentioned, the hydrogen and the nitrogen doesn't work, although the formation of ammonia is endothermic. That's a favored in terms of the thermodynamics. However, nitrogen and hydrogen doesn't work. So therefore, we have to develop the catalyst to lower the energy value. So this is a favor in terms of the thermodynamics. But because of the high barrier, this doesn't work. So catalysis lower the energy barrier by making a new reaction pathway. However, the finding efficient catalyst is not easy. However, because of the inherent importance of the catalysis in the history of Nobel Prize, 12 or 13 subjects, catalytic subjects, were recognized by a Nobel Prize. So important. Well, we are proud of being a chemist because chemistry is beyond the science of mere observation and understanding of nature. Our science is characterized by the capability of generating very high value from almost nothing. Looking at the human history, man-made substances and materials actually determine the quality of our life. Here, the catalysis is one of the most important subjects in chemistry because catalysis is the only rational and general means to produce important compounds in cost-effective, energy-saving, and environmental manner. Currently, the world market of catalysis is about $15 billion US, and the chemical production through catalysis is estimated to be 7 trillion US dollars. Now, the 80% of the chemical products are produced by catalysis. Therefore, we should work very hard to develop efficient, heterogeneous, and homogeneous, and biological catalysts. Otherwise, we are able to survive. Well, in this context, the green chemistry is the most important. Green chemistry, a creative, prosperity-bringing, and responsible science. We are asked to use safe starting materials, renewable resources, and safe solvents. And also we should avoid waste and conserve energy. If we have to discard some waste, that should be green, harmless to the environment. Well, however, even this conservation of energy is quite important. Although the ammonia synthesis, Haber-Bosch process, is extremely important. However, that process consumes tremendous quantity of amount of energy. So we should better. So you should improve the production of ammonia in some way in the future. So the Albert Einstein mentioned problem cannot be solved at the same level of awareness of that created them. So green chemistry is easy to say, but very difficult to materialize. But here you see the resources for chemical synthesis. Now we use some petroleum and coal, the fossil resources like these, and also you can use biomasses like these, and also palm oils in this country, and also we use some simple inorganic compound like these, but notably many of these compounds do not react without catalyst reagent and enzymes. So we should manipulate such compounds to make the atomic rearrangement to make an important compound. So, however, the catalysis is necessary to achieve that. Well, now, then we can synthesize such a very complicated compound. So the state of the art of organic synthesis is amazing. So such compound is completely different from the starting material, which I showed in the previous slide. And this compound is highly functional, and they have correct stereo chemistry. Very, very difficult to synthesize. But some synthetic expert can make such complicated compound which survive, which support our civilized society. Well, the synthetic chemists, experts, are proud of their capability to synthesize such a compound. But we still have some problem. This is a beautiful Malaysian cuisine. These are beautifully done. But you should not forget that your chef has thrown away many kinds of, and large quantity of waste somewhere, right? The current situation of chemical synthesis, like such a Malaysian cuisine. Roger Sheldon emphasized the importance of E-factor. In order to obtain 1 kilogram of gasoline by naphtha cracking, you produce only 100 grams of waste. However, important compound is produced by step-by-step synthesis, thereby waste accumulated. So, in order to synthesize commodity chemicals, 1 kilo, you discard 1 to 5 kilograms of waste. Fine chemicals, 5 to 50 kilograms. In order to make important pharmaceutical drug, 1 kilo, you have to discard the 25 to 100 kilo of unwanted waste. Of course, the environmental impact is highly dependent on the nature or properties of the waste, and also you should carefully evaluate the risk and benefit of the such a product. So, some important drugs, anti-cancer agent, are useful, but that produce a large quantity of unwanted waste. But you need such a anti-cancer agent. Well, this is a current situation. So, in any case, the green chemistry is a key issue of chemical manufacture in the 21st century. Without green chemistry, the chemical manufacture cannot survive, and human beings also unable to survive. So, chemists have an immense responsibility to materialize green chemistry. Well, this is an example of oxidants. So you need a reducing agent and also the oxidant to convert the organic compounds to organic compounds. Well, the atom economy is very important. So now we are using such type of inorganic oxidant. However, we produce such unwanted co-products atom economy, I mean the active oxygen, is just 10 to 20%. And chemical reaction using such compound produces such unimportant, unwanted waste. Oxygen is, of course, the ideal oxygen. But I feel that hydrogen peroxide is also one of the most useful and ideal oxygen because the co-product is just H2O. So H2O2 is a formal product of hydrogen and oxygen. And indeed, the hydrogen peroxide is produced by combining hydrogen and oxygen in a large scale. And if you have a good catalyst, then you can oxidize the organic compound and leaving the just water. That's harmless. The atom economy is 47%. It's very high. So this is my work. We wanted to use hydrogen peroxide for the synthesis of adipic acid. So adipic acid is one of the most important chemicals which is used mainly for the preparation of nylon 6,6. Currently, the nylon or adipic acid is produced from benzene in such way. Benzene is hydrogenated to give cyclohexene, which is oxidized by air to form this type of compound, and then that's oxidized by nitric acid to form this important compound. However, in this great process, the emission of N2O is unevitable. This is very effective, but the N2O produced in such a large quantity catalyzes the ozone destruction, and also N2O has a greenhouse effect, and also N2O causes acid rain and smoke. But now the manufacturing adipic acid produces N2O in a large quantity. Of course, the company can recover N2O and decompose to give nitrogen and oxygen, but that requires a large energy. So my route is here. Some Japanese companies succeeded in the synthesis of cyclohexene from benzene, and this can be oxidized by hydrogen peroxide by using some catalyst to produce clean this adipic acid by removing just the water. This is the mechanism. We could, so in laboratory, we could oxidize 100 grams of cyclohexene to give analytically pure adipic acid in this quantity by using the hydrogen peroxide and this catalytic system. Well, this is a mechanism. This double bond is oxidized to give this one, and this is hydrolyzed to give this diol, and this alcohol is oxidized to give hydroxy ketone. And this bond is oxidized by hydrogen peroxide, this one, and this alcohol part is again oxidized by hydrogen peroxide to give this one. And finally the hydrolysis is hydrochloric acid. This is a very clean reaction that uses only 4 molar amount of hydrogen peroxide and water. That's very clean reaction. So this is a typical typical example of the green chemistry. Also, my profession is catalytic hydrogenation. That is a core of chemical industry. So hydrogen gas is clean resources. We can obtain hydrogen very easily, very clean resources. But what I did is actually the asymmetric hydrogenation. Well, this is the ultimate idea of green chemistry. In the presence of a catalyst, hydrogen molecule is incorporated in CC double bond or CO double bond to make such type of compound. Both hydrogen atoms are incorporated in the substrate to give this type of compound without any waste. Very clean reaction. That's green chemistry. Also, we succeeded in the asymmetric hydrogenation. If you take an ordinary catalyst, you obtain both left-handed and right-handed molecules. But by use of our new chiral catalyst, you can obtain either left-handed molecules or right-handed molecules. That's extremely important because handedness, right-handed molecules, left-handed molecules are quite different if they are involved in our life. Well, this is a left-handed and right-handed molecules. But in many, many cases, left-handed and right-handed molecules have different biological or physiological properties. This is sodium glutamate, left-handed sodium glutamate, and this is a right-handed glutamate. So the left-handed glutamate is a flavor enhancer. The trade name in Japan is Ajinomoto. Right? And right-handed sodium glutamate is bitter. And we are using only sodium left-handed glutamate for the flavor enhancer. But this and this taste different. But in many cases, left-handed and right-handed molecules smell different. This is left-handed limonene. That is a component of orange. However, the right-handed counterpart is present in a lemon. They smell different. So if you introduce oxygen here, you end up with the alcohol, right-handed carbon. That is a component of a spearmint involved in the chewing gum and also the many cosmetics. And however, the left-handed counterpart of this one is a component of caraway seeds. Chef is using this compound for making nice meat. Well, as I mentioned, the left-handed and right-handed smells and taste quite differently, but such a difference became more serious when these are involved in a pharmaceutical drug. We had anandamide tragedy in the late 1960s. Some of you may remember, the senior people may remember that. People say right-handed anandamide is a good tranquilizer, while the left-handed counterpart is teratogenic, causing fetal malformation. Well, however, the commercial tranquilizer